Assalamu alaikum wa rahmatullah, and welcome to all of our beloved viewers to the Voice of the Cape's Facebook page and the VOC's YouTube page. My name is Amir Adams, and I will be conducting the session of today's Matric revision. And this is where we have facilitators or experts in various subjects who will be giving advice, guidance, and their discourses to all of our matriculants who are preparing for the upcoming NSC exams, inshallah. For today, we have none other than our sister Zainab Afrika, who is from Supreme Scholar, and she is going to give over content and facilitate today's matric revision session dedicated to all of the physics students out there, inshallah. As a reminder, this is the Voice of the Cape's annual online matric revision program for the year 2024, and it is in line with our sponsor who sponsors this matric revision session, and that is the Two Oceans Graduate Institute, an accredited online platform where you can become a primary or a high school teacher by studying in the privacy of your own home. If you'd like to find out more details pertaining to our official sponsor for this year's matric revision program and find out more about what they have to offer, you may visit their website www.togi.ac.za, or you may call them on 021 829 7015. Without further ado, we are honored to be engaging with our sister Zainab Afrika as our facilitator for today's matric revision session. And of course, Sister Zainab Afrika is from Supreme Scholar. She will be going through today's content, and that is for all of our physics students, inshallah, preparing for their physics paper one, inshallah. Without further ado, we hand over to our sister Zainab Afrika to facilitate today's session, inshallah. All yours.
Shukran, jazakallah khair, Brother Amir. Okay, Bismillahirrahmanirrahim. Today we are going to start on the topic of electricity. Our previous session we did electrostatics, and that was divided into two parts because of the nature of the content. Today this will just be only part one, because hopefully inshallah I will manage to get all the content that is needed in one session. Okay, and so we're going to speak about electricity. We're going to understand how Ohm's law works. We're going to see what are the components of a circuit and how we do calculations. Okay, so just contents for today's session. We're obviously going to understand what is potential difference. We are going to define it, and we're going to obviously unpack the components of how this fits into a circuit. We are going to apply what is a conductor, what's a non-ohmic conductor, and then we are going to talk about Ohm's law, and obviously finally we are going to do some circuit calculations. Okay, so before we get started, let's just go into a few definitions, and there's a few points that I would like to talk about with regards to these definitions. Number one, we're going to talk about potential difference. Now, potential difference is an important aspect when it comes to it is measured first of all in volts, okay, and it basically measures the amount of charge flow. Okay, so basically in formal definitions, okay, the work done in a moving charge from a point of a low potential to a point of a high potential in an electric field. Okay, so it's called the voltage basically. Okay, so from one point of the circuit to the next point, the voltage or the potential, the measure of the potential difference is what is the work that is done in each charge that is moving or each current that is moving through this conductor. Okay, then obviously we talk about electric current. We cannot have, or we cannot define electricity without a current, because electricity is one of the most important things in our lives today, right? Everything requires electricity. Without electricity, we'll call it the dark ages, right? So the electric current, and how do we define that? That is the number of charges passing a point in a second. So remember, we spoke about charges, and hence I'm drawing off the knowledge based on our previous session where we spoke about charge. Okay, we spoke about positive electrons, negative electrons, and we spoke about their movements, okay, how they come together and how they separate. Now, those charge, if it's moving at a specific speed, can generate a current, okay? And so the number of charges that is moving past a specific point at the time is called an electric current. Okay, then resistance. I love the concept of resistance. It's just a beautiful thing to think about, even in practical life, right? So in an electric circuit, there has to be resistance. Okay, you cannot have any flow of electricity, even these massive turbines, without any resistance. Because what's going to happen is you're going to have an influx of electricity that is not going to be, it's not going to have a stable flow. Okay, and so they say that human beings always choose the path of least resistance, okay? And same in electricity, we choose the path of least resistance, but there has to be resistance nonetheless, okay? Similarly to life having ups and downs and challenges, it's the same in the physical phenomenon, okay? And so basically, when we talk about resistance, we talk about conductor to impede or to resist or to stop the movement of a charge given by the ratio of potential difference across a conductor and current passing through. Know this definition, but you just need to understand it. Okay, so basically it opposes or it opposes the current. Okay, so when we talk about resistance, okay, we're going to see what are the different types of resistance. Resistance plays a role in the electric circuit. It's in and of itself. Okay, then obviously we cannot talk about Ohm's law without talking about, or we cannot talk about electricity without talking about Ohm's law. Okay, so the first thing I want to say at the beginning of the physics paper is going to have a definition. Okay, and so when we talk about current or we talk about electricity, we talk about Ohm's law. Okay, and directly proportional, it's the same thing. Okay, so in every definition of physics, whether you're dealing with Newton's laws, whether you are dealing with electrostatics, whether you are dealing with impulse and momentum, there's going to be a relationship of direct proportionality and inverse proportionality. So Ohm's law says that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points and inversely proportional to the resistance of the conductor, provided that the temperature remains constant. So, in other words, the potential difference and inversely proportional to the resistance. Okay, so C is equal to delta V over delta R, or C is equal to V over R. Okay, and then we're also going to talk about the concept of EMF and how that works. Okay, the internal resistance of a battery. Okay, like everything has some sort of resistance, and how does that contribute to the overall effect of an electric circuit? Okay, so let's quickly do a little bit of revision. Okay, so we said that Ohm's law governs the relationship between current, potential difference, and resistance for that matter in a electric circuit, provided that it is at constant temperature. Okay, so I is equal to V over R. I is the symbol for current, V is the symbol for potential difference, and C is the symbol for resistance. Okay, obviously things that obeys Ohm's law are called ohmic conductors, and the ones that do not obey Ohm's law is called non-ohmic conductors. All right, so when we talk about conventional current, this is very important. Conventional current flows from positive to negative, but electrons go from negative to positive, so they are attracted towards the positive side. Okay, we are attracted towards positivity generally. Okay, when people are good and they're positive, we feed off that energy, right? So electrons flow from negative to positive, but in current, in electricity, we call it conventional current. So the current will then flow from positive to negative. Okay, and so that's just important because sometimes that can confuse us. They can ask us in which direction would the current flow? Okay, and we need to be able to answer that. All right, so that's just an important point I wanted to note there. Then let's talk about the components of a circuit. Okay, so a component of a circuit, there's going to be different components that you guys are going to be exposed to. Sometimes they're going to give you the symbols in green, and sometimes they are going to give you white. Okay, usually it's this. These are the symbols that we use. So for a switch, okay, it usually looks like this. They'll tell you, we'll see when we do some questions, they'll tell you the switch is open, the switch is closed. We have a cell, a positive and a negative terminal. Okay, more than one cell makes a battery. Okay, so more than one cell makes a battery, but sometimes they'll just have one cell there. You can also consider it a battery, but more than one cell is considered a battery. All right, then we have a lamp with the X in the middle. We have the voltmeter, the ammeter, the resistor, the variable resistor, and the motor. Okay, so these at the bottom here are all forms of resistance: a motor, a variable resistor, and a resistor itself. Okay. Okay, now we're going to talk about the two types of circuits. Okay, we have circuits in parallel and circuits in series. So I'm going to spend a little bit of time just explaining and um, talking about this type of circuits because it's important to understand what the difference is and why it is important. Okay, so series mean that the circuits are next to each other. Okay, they are next to each other. Now, resistors in series, okay, of voltage dividers. Okay, you see, series resistors divide potential difference proportionally. So the bigger the resistor, the higher the potential difference. I'm going to explain that properly. So the first thing I want you guys to note is that resistance is series of voltage dividers. Resistors in parallel current dividers. Okay, we'll get to the parallel part. But let's just focus on this at the moment. So resistance series are voltage dividers, or you can say is series resistors divide the potential difference proportionally. So the bigger the resistor, the higher the potential difference. Okay, so like we said that the resistance is going to be proportional to the voltage. Okay, so if I'm increasing the resistance, I'm going to increase my potential difference. If I decrease my resistance, I'm going to decrease my potential difference. And so basically the sum of the resistance or the sum of the voltage are just going to add up together. Okay, so current for series circuits, let's say this again, for series circuits, currents remain the same, the voltage will change. Okay, so in each voltage, so the 2 volts will have a different resistance to the 4 volts will have a different resistance to 10 volt. Okay, because they are resistors in series divide voltage. It divides the potential difference. Okay, and so when we calculate the resistance, you add them all up together. Okay, now there are advantages and disadvantages to all of this. Okay, so one of the main advantages is that for resistance in series, right? They could end up if one resistor breaks, it can sort of affect. It doesn't necessarily have to affect the whole current. Okay. So basically, what I have is series circuit save energy because the energy shared among is connected to each resistor. Okay, so that is one of the advantages of having a series circuit. The disadvantages that is if there's only one resistor, then the whole circuit obviously is going to crumble. Okay, the whole circuit is going to crumble. But another advantage could also be that the total resistance increases as more resistors are added and the current decreases. Okay, this is another important aspect of series circuits. Okay, so remember the advantage of connecting things in series, it depends on what current are you trying to create or what system is connected to this current. Okay, series circuits can save energy, definitely. Okay, because why? Again, because the energy is shared among each resistor, so that's an advantage. Disadvantage, obviously, if one breaks, then then you've disconnected the entire circuit because it's all basically next to each other. Okay, so if one point at the circuit breaks, it's going to disrupt the entire circuit. Okay, and then let's talk about parallel resistance. Okay, parallel resistors are current dividers. Okay, so the bigger the resistor, the lower the current. Resistor, the lower the current. Like I said, resistance, a current chooses the path of resistance. Okay, we were always told current chooses the path of least resistance. Okay, so now the total resistance is a bit different because they are connected parallel to each other. Okay, they are connected parallel to each other, which means now if you want to calculate the resistance, is going to be 1 over R1. So 1 over R total, sorry, is equal to, or 1 over R net is equal to 1 over R1 plus 1 over R2 plus 1 over R3, depending how many resistors you have in parallel. Okay? Usually most things in our homes or around us is connected in parallel. Why? So, because remember with series, if one breaks, the entire circuit collapses. But if each resistor in parallel is controlled individually, right? So when the one breaks, the circuit can still continue. Okay, so most things are connected in parallel. Okay, and then another advantage could also be that adding more resistors decreases the total resistance and the current increases. Okay, so the more we add, we're going to decrease the current. Okay. Sorry, the more we add, we are going to increase the current. Okay. Yeah, so like I said, most things in our homes are connected in parallel. Most things are connected in parallel. All right. So those are just the main differences. Another thing, one very important thing that I think most of us forget to mention is when we are doing the calculation of calculating resistance in parallel and calculating resistance in series. Okay. So now when we are calculating resistance in parallel, remember I said 1 over the R, so 1 over R total is equal to, like you can see here, 1 over R1 plus 1 over R2. Okay. So once you find the answer, let's say I have three resistors and they are all in parallel. So I have a two a, let's say 2, 3, and 4. Okay, 2, 3, and 4. Okay, so a two resistor, a 3 resistor, and a 4 resistor. I must say 1 over 2 plus 1 over 3 plus 1 over 4. You get an answer. That answer at the end you must step n times. Okay, so let's say we have 1 over 2 plus 1 over 3 plus 1 over 4. Okay, together that should make 1 over 9. Okay, 7, 8, 9. Yeah, 1 over 9. You flip it, it becomes 9 over 1. Okay, so 9, then that in total the resistance will be 9. Yeah, the resistance, the in total the resistance will be 9. Okay, so just remember when we are talking about total resistance, the resistance you have to flip. So once you've added all the resistance in parallel, you must make sure that you flip the answer at the end. Okay. Then we talk about EMF. Okay, we're going to talk about EMF, and EMF is the internal resistance of a battery. So remember, in each electric circuit, an EMF, okay, an internal resistance or internal voltage for that matter. Okay, now in a battery, they're going to ask you calculate the EMF of the battery, the total energy of the battery. Okay, and so the question is asking us here, what happens to the lost volts when the external resistance is increased? Remember, you have internal resistance, which is of the battery, and you have external resistance, which is of the circuit. Okay, so increasing the external resistance of a circuit will cause the potential difference to increase and the current will decrease. Because remember, potential difference and current are, in terms of EMF, are inversely proportional. Okay, in terms of external resistance, they are directly proportional. Okay, therefore, more voltage is required in the external circuit. Okay, so the lost volts should decrease to accommodate the increasing potential. Let me explain this properly. We have something called internal resistance and we have something called external resistance. Okay, the external resistance is once this current leaves the battery. Okay, so let's say from this point onwards, because here you can see the EMF is, here we go, EMF is 6 volts. Volts that are actually being generated through this battery, through the circuit. Okay. Why do we have lost volts? Is it actually lost? Not necessarily. Lost volts just mean that the battery has its own potential difference. So the battery might be a 6-volt battery, but it only generates 4 volts. So it only reads 4 volts because of the internal resistance. You can see here there's a small R. Okay. So once the current starts flowing here, it's going to start reading 4 volts. Okay, it's going to come through 8 volts. So remember, when you're calculating EMF, you are using the internal resistance. So you're using the 4 volts. Okay, when you're calculating the external, you are using 6 volts. Okay, so just note that difference is important. We are going to look at some questions shortly. Then lastly, before we get on to the questions, we're going to talk about factors that are affecting the resistance of a conductor. That could be a very simple question to answer, but it's something I feel like we do need to go over. So what are things that are the factors that affect the resistance? Because here we talk about resistance. Everything is in relation to resistance. Okay, so we have type of material. Number one, is this material a good conductor or is it a bad conductor? Okay, usually for electricity, copper is a good conductor. Aluminium could also be a good conductor for electricity. Okay. So yeah, and since nickel has a higher resistance than copper. Okay, so that's one thing that could affect the resistance. Okay, it's the type of material. The second thing that could affect resistance is the length of the conductor. Obviously, the longer the conductor, the higher the resistance, because the resistance will have to travel a long distance. Okay, the shorter the conductor, the less resistance there is. Thickness, obviously, the thicker the conductor, the lower the resistance. Okay, because you have more pathways of charges to flow. So a thin conductor has higher resistance because everything needs to pass through a small point. But if I have a thicker conductor, I have more space for currents to flow. So instead of one just passing at a time, I have more flowing through. Okay, so the thicker the conductor, obviously the lower the resistance, and then temperature. Okay, higher the temperature of the conductor, the higher the resistance. Okay, the lower temperatures, the lower the resistance. Okay, now what we're going to look at is some questions, and this will be all the set of questions we're going to do, and then we're going to end off with the. So basically, this is the last about the last slide. Like I said, electricity is a very small section. Okay, it's a section that requires you just to understand the components. There are obviously many ways in which this can be asked, but it's a small section in terms of the understanding, and so it's a good section to gain marks in. Okay, it's a very good section to gain marks in. Okay, so let's look at the questions and let's answer them together. It says the battery in the following circuit has an EMF of 24 volts and an internal resistance of 1.5 ohms. Okay, R is a resistor with an unknown resistance. The light bulb has a resistance of 15 ohms. The resistance of the switch S1 and S2. Okay, and so the resistance of switches S1 and S2, emitter and conducting wire can be ignored. Now, number one, they say state Ohm's law in words. Okay, state Ohm's law in words. We've stated it, let's state it together. Okay, the potential difference, the current flowing through a conductor is directly proportional to the potential difference and inversely proportional to the resistance. Okay, at constant temperature. Remember, temperature has to be constant because if temperature is not constant, remember when we spoke about temperature being one of the factors that affect the resistance. Okay, so if temperature is not constant, it means that Ohm's law is not going to apply. Ohm's law can only apply when there is constant temperature. Okay, then number 2.2. What is meant by the internal resistance of a battery? That's very important. So I think it's something we can look at. What is meant by internal resistance of a battery? So basically, it just means that the battery itself has an internal resistance that's going to oppose the flow of charge. Okay, that's internal resistance. Take it for what it is. Okay, where the battery has an internal resistance. And what does resistance technically mean? It opposes the flow of charge. Then 2.3, calculate the effective resistance of the 10 ohm resistor and light bulb. Okay, so they say calculate the effective resistance of the 10 ohm resistor and the light bulb. Look where the 10 ohm resistor is. Okay, before we actually even tackle this question, are these connected in series? Are the resistors connected in series or in parallel? Okay, so we can see there's two connected in series and there's one connected in parallel. So remember the resistance formulas for resistors in series and resistance formula for resistors in parallel. There's a difference, and that's important. There's the reason why there is a difference. Okay, so now this is obviously in the external circuit, and we know that the total resistance is 1 over R1 plus 1 over R2 plus 1 over R3, but you're only going to calculate the parallel component. So 1 over 10 plus 1 over 15 is equal to 1 over 6. Like I say, tip. You need to tip it over. So it becomes 6 over 1, which is just equal to 6 ohms. I hope that makes sense. Very good. 3 easy marks. Okay? Let's continue. Then, when the switch is closed, the bulb converts 576 joules of energy per minute. Calculate the reading on the voltmeter when the switch is closed. Okay, so now the switch is closed. We want to calculate the reading on the voltmeter V2. So the reading across the parallel connection. Okay, take a look at that. It's the reading across the parallel connection. All right, so when we are looking at, they ask us to calculate the reading on V2. Now, I want you guys, it's a small calculation. It's not, I want you guys just to pay attention to what are the steps they use to solve this, because it's a formal question. Number one, they use the formula work is equal to V squared over R. All of these formulas are given to you in the formula sheet, okay? Work is related to energy and power is related to energy, and all energy is related to electric current, okay? So this is also part of electricity, and these are all just formulas that you will find on your formula sheet. Okay, the relationship between work, voltage, current, the relationship between power, energy, current. So they'll say, how much power is dissipated? Okay, how much power is dissipated? Because obviously the amount of electricity that's used has got to do with power. Okay, and it has to do with work. Okay, so V squared actually over R multiplied by time. Okay, because they give you those components. So you see they give you time, they give you work, and they give you the resistance. Okay, so V squared. So we're looking for V squared, 576. And remember we're talking about the parallel connection. So it's 570. If you manipulate the formula, V squared will be the subject of your formula. That's equal to 144. And so you square root the 144 and it will give you 12 volts. Okay? Fairly easy calculation. Take a minute just to look at it, to analyze it. Okay? So then the second question, they ask for current. They say 2.5 ask us to calculate current. So it says 2.5 calculate the reading on the ammeter. Okay. Now because we have the volts of V2, we can calculate the reading on the ammeter according to Ohm's law. Ohm's law is I is equal to V over R. But of the P, you see that the P there, the P subscript, that refers to the parallel connection. Okay. That refers to the parallel connection. So it's going to be I is equal to V over R. V we've just calculated was 12 volts. We've calculated in the very first question what the ohms were for the parallel connection. And so for the amount of current that is flowing past the parallel connection is going to be 2 amps. Okay, it's going to be 2 amps. Lastly, the last question, they're asking for the internal resistance. Now look carefully. So they say determine the resistance of the battery, of the resistor R. Okay, but you can see the resistor R is the resistance that is going to be read by the battery. So let me just quickly show you. This will be, we have the resistance of the external circuit because it's the external circuit that it's a parallel circuit, it's a parallel connection, and we have calculated the resistance. But now this reading that's coming over here is reading the resistance of the battery. Technically, it is reading the internal resistance of the battery. Okay, it is reading the internal resistance of the battery. So we need to use the EMF formula again, which all will be on your formula sheet. Okay, so we have EMF is equal to I, current, R, which we are looking for, plus more R, which is the external. There is the relationship within the battery between the external circuit and the internal circuit. Okay, there is a relationship between the two. So, EMF, the total EMF is 24 volts. Okay, 2 is the current, we calculated it. 6 is the external resistance of the parallel connection, which we calculated, and 1.5 would be the, why are we multiplying by 1.5? We are looking for, 6 plus 1.5. Remember, there's two types of resistors. There's the one in parallel and there's the one in series. Okay, so you add the parallel one and the series one, you add them together, so it's going to be 6 plus 1.5. Okay, then obviously you're looking for R, and that would be your main subject of your formula. You just cross cancel, or you sort of solve for X, you make R the subject of your formula, and R would be 4.5. Okay, before I end off, there is just two things I wanted to mention when we are dealing with parallel circuits and series circuits. This was a parallel circuit, okay? Usually a bit more difficult than a series circuit, hence why I chose it. But when you have a combination of a parallel circuit and you have a combination of a series circuit, make sure that you add the parallel combination differently. And then once you've done using the formula of 1 over R1 is equal to 1 over R2 plus 1 over R3, then you go and you add the series circuit. Do not add them together all at once, because the series connection is quite different to the parallel connection. The way resistance flows in the series connection is different to the way resistance is going to flow in the parallel connection, which means your answers will be different. So you first calculate for the parallel, then you would add it to the series connection. Also with EMF, know what's the external resistance, know what's the internal resistance, okay? All the formulas are there. Fairly straightforward. Like I said in our previous session, the answer is in the question, okay? Everything is given to you, plus a formula sheet. You need to take the values, take the knowledge, use the relationships between current, voltage, resistance, power, and work, and you then apply it to a formula to get your correct answer. Okay, so from me for electric circuit, I hope this short and quite easy lesson was beneficial to you. I will see you in our next session, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.
Wa alaikum salam wa rahmatullah. We say shukran, jazakallah khair to our sister Zainab Afrika for facilitating today's Matric revision session. And that, of course, was dedicated to all of the physics students who are preparing for their upcoming NSC exams. As a reminder to all of the viewers, this is the Voice of the Cape's annual online Matric revision program for this year, particularly 2024, that is proudly being sponsored by the Two Oceans Graduate Institute, an accredited online platform where you can become a primary school or a high school teacher by studying in the privacy of your own home. For more details, you may visit their website, www.togi.ac.za, or you may call them on 021 829 7015. As a reminder, as always, beloved viewers, to the Voice of the Cape's YouTube and Facebook page, please forward and share this link of the Voice of the Cape's Facebook page and YouTube page to all of the matriculants who are preparing for their upcoming examinations. And of course, this particularly dealing with all of the physics students, inshallah. Please forward and share this link with them as they prepare for their upcoming NSC exams. Once again, we'd like to say shukran to our dear sister Zainab Afrika from Supreme Scholar for so beautifully facilitating today's session. And we hope that everyone has benefited from our side of the Voice of the Cape. We say to you all shukran, jazakallah khair, and bayt makasi. Wassalamu alaikum wa rahmatullah.